Now let's look at some general properties of currents and voltages which hold true regardless of what elements you connect. So they are not properties specific to any circuit, but general properties of currents and voltages in a circuit. Okay. So firstly, let's consider a node with a number of elements connected together. Okay. And let me define the current in each element to be flowing towards the node. I1, I2, I3 and I4. Okay. So now there is a law, Kirchhoff's current law. Kirchhoff was the scientist who first stated this, which says that sum of all currents entering a node is 0. Okay. Now, why does this make sense? Let's imagine that the sum was not 0. What would that mean? What is current after all? Current is rate of flow of charge. So that means that there is some net rate of flow of charge into this node. Okay, if the sum was not 0, then there is some net flow of charge into the node over time. Okay, so that means that the charge is either accumulating at the node or somehow charge is spontaneously destroyed or created. Okay, so neither of that is true. Charge is conserved, it's not destroyed or created, that much is true. And also we will make the assumption that there is no local charge accumulation. Okay, now this is true when the circuits are small and so on. Okay, compared to something. So unless you have some very large circuits operating at high frequencies, this much is true, that there is no local charge accumulation and the sum of currents flowing into a node will be equal to 0. Now sometimes this is stated differently. You could also equally well say that you can consider currents in the opposite direction, that is leaving the node, and say that the sum of all currents leaving the node is 0. Okay. Now if you call this current as I1 dash, it is simply equal to minus I1, because I told you earlier that plus 1 ampere going from A to B is the same as minus 1 ampere going from B to A. Okay. So this is simple, and sometimes it's also stated as sum of currents entering equals sum of currents leaving. Okay. Now whether you choose to represent a current as entering the node or leaving the node is up to you. Any current can be thought of as entering this node or leaving this node. What will happen is the value of the current will get reversed in sign. Okay, you can say plus 1 ampere is flowing through this element into the node, or minus 1 ampere is leaving this node. They are exactly the same. So you can use any of these definitions, and any of those currents could be positive or negative. So, but just do it consistently so that you get the correct answer. Okay, don't get confused by polarities of current, whether the currents are considered to be entering the node or leaving the node. Now, what does this mean? You can calculate an unknown based on the other currents. Okay. So let's say I1 happens to be 1 ampere, I2 is minus 2 amperes. Let me get rid of this red stuff, it could be confusing. And I3 is unknown and I4 is 1 ampere. Okay. We know that I1 plus I2 plus I3 plus I4 is 0. So that means that 1 ampere minus 2 ampere plus the unknown value of I3 plus 1 ampere equals 0. So this means that I3 has to be equal to 0. Okay. And for different numerical values of I1 and I2 and I4, you will get different values of I3. Okay. Now here is an analogy for Kirchhoff's current law. Let's say you have some pipes connected together to form a junction. I'll just take 3 pipes. Okay. Now let's say water is flowing here at 10 liters per minute and water is flowing here at 15 liters per minute. You obviously know that water will flow out here at 25 liters per minute. Okay, this is all that is, right? Kirchhoff's current law is the same thing, but it relates to flow of charges instead of flow of water. That's all. And this makes the same assumptions that we did for Kirchhoff's current law. That is, water of course is not magically being destroyed or created from this node. If that is the case, then what is coming out will be more or less than the total of what is going in. It also obviously means that this pipe is not leaking here, etc. If it were leaking, what's coming out here would be less than these things. The way we stated Kirchhoff's current law is to take flows only towards the node. So if we do that for this, we can say that water is flowing here at plus 10 liters per minute and here at 15 liters per minute. And if we have to take this flow also in this direction, we know that water is going out, but in this direction it is minus 25 liters per minute. And the sum of these three, minus 25 plus 10 and plus 15, is obviously 0. And you could equally well take all of them going outwards. You can consider this to be going out at minus 10 liters per minute and this going out at minus 15 liters per minute and this one going out at plus 25 liters per minute. So obviously the sum of these things marked in blue is also 0. Okay.